Alright, welcome to Crazy Probabilities, problem number 1. The bag contains 7 purple and 7 orange pieces of bubblegum. 3 marbles are selected. What is the probability that at least one is orange? From this problem, I conclude this. I'm trying to find the probability at least one of the pieces of gum is orange. Now that probability can be broken down into 3 smaller probabilities. The probability that we're going to get 1 orange, the probability that we're going to get 2 orange, and the probability that we're going to get 3 orange. From this we have to find those 3 probabilities, and to do that we're going to have to count all these situations. The first situation implies that we're going to have 1 orange and 2 purple. We find the number of ways we can get orange and the number of ways we can get purple by using combinations. The order that we get these numbers in don't matter. That's why we use a combination. And we're going to divide that by the total number of ways we can choose 3 balls, or 3 pieces of gum. When we're looking for the probability of choosing 2 orange pieces of gum, that means we're going to get 2 pieces of orange gum, 1 piece of purple gum. We find that probability by finding the number of ways we can be successful by getting 2 pieces of orange gum, and then the complement of that 1 piece of purple gum, dividing that by the total number of outcomes there are when we're choosing 3 pieces of gum. The third probability, break it down, 3 pieces of orange gum, no purple gum. That probability is given by the ratio, the total number of favorable outcomes divided by the total number of outcomes. We really don't need to find the combination of 7, choose 0, because that's 1, anything choose 0 is 1. When we run this through our calculators, we get 84 plus 42 plus 4, all divided by 165. That gives us a subtotal of 130 over 165. When we reduce that, it gives us 26 out of 33, which is just about 80%. Crazy probability number 2. Today, I was walking down the lunch, I dropped 6 coins onto the floor. I want us to find this probability. The probability that at least 4 of the coins came up heads up. Like the last problem, we have 3 different probabilities. The probability that 4 of the coins were heads up, the probability that 5 of the coins are head up, and the probability that 6 of the coins are head up. We have to find each one of those probabilities. When we do that, to find the probability of 4 coins ending up heads up, since the probability of getting a heads and a tails are complements of one another, there's only 2 possible outcomes, and one of the possible outcomes is heads and the other possible outcome is tails. Each one of these represents the probability of getting a heads or a tails. Here I've marked these first 4 as heads, these last 2 as tails. A lot of kids get confused thinking that these are all representing heads. They're not. Remember, the probability of getting heads and the probability of getting a tails is 50%. And there's where some kids get confused. To account for that, we want to get 4 specific coins being heads or tails. We're going to do 6 choose 4, When we multiply this out, it gives us 15 out of 64. Probably around 20%. We find the probability for getting 5 heads in a similar manner. In fact, it's exactly the same way. Instead of being 1/2 to the 6th power times the combination of 6 choose 5, or 6 choose 4, now we use 6 choose 5 to give us 6 over 64. And when we get 6 heads, there's only one way to get that, and that is to get all 6 coins heads. When we add these 3 fractions up, it gives us 22 out of 64 is our subtotal, and when we reduce that, it gives us 11 over 32. If we just take a look back for a minute, we looked at 2 pretty cool problems today. Just a couple things to think about. A little exercise I like to do when I come across some new problems or some problems I haven't looked at in a long time. I like to compare how the problems are the same and how they're different. Some people might call that compare contrast. I don't know, whatever you want to call it. Each one of the problems today were similar because we had one big probability, but it was made up of the sum of 3 smaller probabilities, and we needed to add those probabilities together to find the overall probability. Now, each set of 3 probabilities here was calculated differently. In the first problem, we had a lot of total outcomes, 165 to be exact. I couldn't even imagine counting out with a tree graph. That'd be crazy. In the second problem, the probabilities found by using simple probabilities. I hope you enjoyed this video blog of simple probabilities.